All right, here we go. So, going back to our previous section, when we talked about introduction of inverse functions, right? You remember us doing that?
Yeah.
Talk about that. Sine is what's the inverse called?
Oh,
cosecant or that's the inverse. So cosecant is the inverse of sine. What's the inverse of cosine? Secant. And what's the inverse of tangent? Cotangent. There we go. Cotangent. Okay. Those are our inverse functions. Okay. Our not inverse, our reciprocal functions. Inverse is now our when we don't know our angle. I'm over mumbling about nonsense. Inverse and reciprocals are tend to accidentally mix up a lot, right? Because you're like, oh, what is this? Inverse is saying you know the ratio, but you don't know the angle, and you're looking for your angles. Okay, when you're using your inverse, you're seeking your what angles. You're like, what angle makes this true? Okay, so if you look right here, this is our sine graph, correct? Our beautiful sine graph or example sine graph. This right here is the partition of it, like from here to here, cut off. But eventually you're getting down to your inverse. And what you're doing is your x's and y's are doing what from the sine graph? They're switching, just like any other inverse function, your domain and your range switches. However, there are limits to our original range. Our range here is only from -1 to 1, correct? And then same thing is going to apply here is that our domain, by the time we get to the inverse, has to also be from -1 to 1, right? A one cycle of our sine function, it can be viewed, it's from -π/2 to positive π/2. You look here from the max to the min.
That means it's not really a function if we have repeating x values.
And that's why it has a restriction on it. Because without the restriction, would it be an inverse function? No. Because in order to be an inverse function, you have to pass the vertical line test and the horizontal line test.
So it's
and without restrictions, we would fail, right?
Yeah.
So that's why when you have an inverse function, those restrictions are applied, and that's why this is our final output of our graph.
Everything has an inverse as long as there are restrictions.
Everything can have an inverse function as long as there are restrictions. Exactly. Okay?
Can you go back for 1 second?
Yes. I can go back. There we go.
Okay. Thank you.
All right. If you have your unit circle, take that out. We're going to need it here in a minute. Forgot about that. Don't ever forget your unit circle.
Wait, okay, Miss Jones, don't look at it. Tell us everything.
What?
You could do it. Tell us everything how you get circle.
Which part of it?
Let's
I'm running a whole deprived on sleep.
Oh, that's no excuse.
You're younger than me. Y'all, no, y'all. I did not. I had less sleep in my youth.
People need more sleep.
I had way less sleep, and I feel like my radiance in the first one. I was like in the first one.
All four.
We're just gonna do first quadrant. 0, power 6, power 4, pi over 3, and pi over 2.
I feel like cheating.
And as long as I know that, I'm good. I only need to know quadrant 1, and that's I know the rest. As long as I know quadrant 1, I can do the rest.
Do the rest.
Anyways,
Oh, national state.
we're moving on. Okay. I don't have time for y'all your nonsense. All right, so we have sine inverse of, for example, if I ask you for the sine inverse of 1/2. Okay, you see that? I'm asking for the sine inverse of 1/2. The sine inverse, the values are only between -π/2 and pi/2. What quadrants am I using then?
2 and 2?
No.
1 and 3. Wait, for what? 1.
And my restrictions are between -π/2 and pi/2.
Oh,
what
1 and
quadrant?
4.
1 and 4. I can only use quadrants 1 and 4. So it's asking you, if I have sine inverse of 1/2, I'm asking you, looking at quadrant 1 and in quadrant 4, when do I get the value of 1/2? So if you look on your unit circle, between quadrant 1 and 4, when do I get the value of 1/2? And sine means I'm looking at which one? Y. When does my y equal 1/2?
No, 5%.
It's just at, I need a positive 1/2. So it's at pi over 6. Does that make sense? Because if I'm in the fourth quadrant, what is y going to be? Negative. And I needed y to be what? Positive. Let me pull my unit circle. Yes. Restricted interval. Negative pi over 2 and pi over 2.
So you go clockwise, -2, then go into.
Negative
But
pi.
that would only be in the one
Remember, when you're
third.
negative, you're going clockwise.
Wait, so it
So
would.
that's quadrant
Negative pi over 2.
from negative pi over 2. Yes.
Pi over 2.
That means that in between these are you're from here.
She's going.
You're going the wrong way.
There's
Wait,
no in
Miss
between,
Jones,
though.
Miss Jones, in quadrant,
You're from 0 to negative pi over 2 and 0 to positive pi over 2.
right? Like,
Which is quadrant 4 and quadrant 1.
And you come up to the top, and that's all you get, right?
Yes. You're only from, like, does that make, here, let me draw it.
He does.
I'm gonna draw it. She doesn't understand? Is it just her? Oh, okay. Got it. All right, it's okay. If it lets me write, I will gladly write. Okay, that's not what I was trying. Okay, here we go. This is positive pi over 2. This is negative pi over 2. This is your 0. Your solution resides between these two. So in quadrant 4 and in quadrant 1. Yes? So I'm looking for sine inverse. When does y equal a positive 1/2? Y only equals a positive 1/2 out of my two options in which quadrant? Quadrant 1. So in quadrant 1, when does y equal 1/2? And that's at pi over 6, aka 30 degrees, right? We're right here. That's when I have 1. Does that make sense? Yes, because that's going the counterclockwise. But just think about this also in terms of a number line. You're just from a negative to a positive. So 0 to the negative, 0 to the positive. Okay, which is why it's quadrant 1 and 4. I just realized why this felt like I've already taught this is because I did teach it in trigonometry 13-16 3 weeks ago. That's why. I was like, did we learn this? No, you didn't. My other class did. Crazy. All right. So that's our answer. So theta would have to equal pi over 6. Yes? Which is 30 degrees. Agreed? Is that pretty simple using your unit circle? All right. So using your unit circle, we're going to just kind of do an outline, making sure we're comfortable checking the values. Cool? All right. So if I have theta negative pi over 2, so theta equals negative pi over 2, what is the sign, aka the y value at negative pi over 2? It's going to be -1. Yes? Okay? Just make sure we're good going the other way. All right? At negative pi over 3, what is my sign? At negative pi over 4. At negative pi over 6. At 0. 0. Now we're into quadrant number 1. So these are all from quadrant number 4. And now we're in quadrant number 1. So using your unit circle, what is the sign of pi over 6? 1/2. What is the sign of pi over 4? What is the sign of pi over 3? And do we see the pattern and the connection between the two? They mirror, they're opposites, right? Yes? Okay, that's the thing. You got to be comfortable reading the unit circle So this would be something on the non-calculator part of a test. Okay, you wouldn't have your unit circle. It could be, what is the value of that given this? Okay, so really quick, I want you all to do example number 2. Example number 2, I'm asking you, for what values do I get this for y, right? For what angles do I get y equals 1? Y equals -1/2. Yes, sorry. 1 should be. Okay, so really quick, you have your chart. Now you're working backwards. Does that make sense? So we're going backwards. So quickly, I say you can do it in 90 seconds. What angles give me sine theta equals 1? What angle gives me sine theta equals -1/2? What's our what's up?
For this one, okay,
This.
it's the inverse of negative.
This should be square root of 3/2.
-1
On each.
over 2. That's, yeah. 3/5. Oh my gosh.
I don't know how to answer you yet. I don't know how to answer you yet. B should be sine inverse of square root of 3/2.
Okay, so the inverse of -1/2 would be.
The inverse, sine inverse of -1/2 would be what? Look at our chart.
Okay,
When does y equal -1?
5/6. Oh, negative -5/6.
So my answer is,
Oh, but wouldn't have to find the inverse of that?
that's the answer. It's -5/6.
Negative 5/6. Couldn't, do you have two answers? 5/6.
Which one?
It's been -1/2 be in 2 quadrants.
We're only in quadrants 1 and 4, which is why we only listed those out, right? So we're only focused on looking in quadrant 1 and 4 to find those values, okay? Because that's where it's restricted to. Does that make sense? Yeah, I was coming to do that. I was coming to do it, man. All right, what did we get for A? It's pi/2. Good job. What do we get for B? -5/6. Perfect. What do we get for C? Pi/4. And what do we get for D? Pi/3. Do we feel comfortable using our unit circle to find inverse of sines? Okay. Okay, where are we stuck at?
Like seeing the unit circle in my head.
Okay, that's why, remember I just said when y'all asked me to do the unit circle, as long as I know quadrant 1, I know everything else. So like I typically, on every AP test, I wrote down quadrant 1. I just literally, and I got to get it out. It's on my scratch paper on every single time. And then if I need to go from there, I go from there. But as long as you know quadrant 1, you're golden.
But like -5/3, is it the same as 6? Wait, is it 5/3?
Yes. It's still the same. I'm not taking those values away, but because of what it's,
That's why. The powers of I was thinking 5/3.
but you're not going to write it as that because your restriction is -5/2 to, so it has to be written with the negative, which is why we're practicing. Mhm. And we're not gonna ever go through quadrants 2 and 3, right? Yeah, we don't go through them. So we have to focus on that negative value. Got it? Make sense? Okay, are we feeling good about sine? For now? Because we're going to do cosine. Are we sure? All right, so we're gonna talk about cosine and where its restrictions lie, okay? So your cosine inverse or arc cosine restrictions are between 0 and pi. So it's restricted between 0 and pi. And again, we're asking you, given this value, what is our x that, well, given this x value, what is the theta that makes it true? Does that make sense? However, we're restricted to which quadrants? quadrant 1 and quadrant 2. So we're looking in Q1 and Q2, okay? Okay, the reason being is look at what our range is on our final graph. Our range is 0, x is greater than -1, but less than 1. Do we see that? Less than or equal to 1. So that's why we're only in quadrant 1 and in quadrant 2. Got it? Yeah? Are you sure? Okay, what's no? Oh, don't do that. Okay, here we go. Are you ready to see example and fill in our table? Okay, now unit circle in our brain. Ready? Unit circle in our brain. Cosine means we're looking at which coordinate? X. Only looking at our X. Okay, so the cosine of 0 is 1. Cosine of pi over 6 is? Cosine of pi over 4? Cosine of pi over 3? Cosine of pi over 2? Cosine of 2 pi over 3? Cosine of 3 pi over 4? Square root. Yes. Cosine of 5 pi over 6? And then the cosine of pi. -1. It's a weird 3. It's there. Okay, so these are our quadrant 1 values, and these are our quadrant 2. Okay, using your table, do A, B, and C. Is it an option? Yes, you're asking for what is the radius of theta. There you go. There you go.
Yeah. I'm gonna think, is that even possible?
Wait, so
Yes,
Steve
what
would
about
be
two?
negative pi. What's B?
Is it possible?
No, so.
It would just be.
Do you have that option up here?
You're right.
You don't have it, so don't force it.
So will it, with this type of like.
I mean, I would essentially.
Wait, how many questions are?
Or post that.
there?
I will post the thing. You're what?
Can I have an interview?
Oh, I didn't do it. You want to be one of my videos too? Yeah, it was really sad. What's that?
Okay, not my bad. What was it called?
It's not the way it works.
No, it's Wake Up Light. Wake Up Tours is the bus company. Yes, exactly. And
Greece style.
but no, Emma kept saying, I'm so excited to be going on Wake Up Tours. I'm like, what? No, you're not. We're not taking no black van across the ocean.
My grandparents were in town and I was there, and they're like parked right out there. All the time. I'm like, dude, thank you. Like, they're like, let me see more of your hometown. I've lived here longer than you have.
The week before things were like $90.
Yeah.
My mom looked it up, she was like, we should go for fun, and it was like, oh, it's my hair.
Oh, man. All right, are we ready? What's A? Anybody, everybody, what's A?
Oh, I didn't hear that voice right.
Pi over 2. What about B? Not possible, undefined. NA, not applicable. How everyone write it? Does it exist? Okay. Oh, guys. All right. C, what do we get? Pi over 4. And what do we get for -1/2? 2 pi thirds. Okay, how do we feel about non-calculator cosine inverse? You're geniuses, right? You got this. All right, guess what's next? Tangent, yay! Okay. Okay, tangent. Tangent's a little funky. All right. So let's look at tan. So tan, inverse, it says here, what do you notice? Do we have a restriction? Is there a domain restriction? No, what are our arrows doing? They go forever. So that means that tangent can be applied to the whole shebang. However, it has restrictions on the y. It can't be higher than, look at our y values, negative pi over 2 and pi over 2. So normally, what did those pi over 2 and negative pi over 2 represent? They were our what and our tangent. They were our vertical asymptotes. It says what?
Over there, by the, right there.
No, this one's originally for your tangent. The original tangent function has restrictions at your asymptotes, right? Yeah, agree? So now initially you have negative pi over 2 and pi over 2. Those are our vertical asymptotes, right? Our boundary lines. It's not even equal there, right? I don't know why there's equal sign there, but anyways, I don't think people will be checking their notes. You can't equal an asymptote. You can't. That's the whole purpose of it, right? All right. So if I have vertical asymptotes, when I find its inverses, those vertical asymptotes now become horizontal asymptotes. Does that make sense? So what were once vertical asymptotes are now your horizontal asymptotes. Okay. So your restriction, yes. So now our restriction is our y value can't be greater than pi over 2 and smaller than negative pi over 2. So we're now restricted here. These are our inverse restrictions for tan inverse.
Is that like forever? Because
Tangent is always, you know, the nappy step-headed child who makes it difficult. I know. All right. So we're going to, maybe once you create our table of values, we'll understand it better. Okay. So for tangent, we're still going to be using only quadrants 1 and quadrant 4. Okay. Quadrant 1 and quadrant 4, we're going to use for tangent. And that's because that's where our y values have those restrictions, right? That's when y, our theta is now our y, right? So we're going from theta being pi over 2 to theta being negative pi over 2. Because if we look back at our graph, what is the highest our theta can be? And what's the lowest our theta can be? So what that places in what quadrant? 1 and 4 by default, the fact that that's where our theta restrictions are. Does that make sense? All right, so let's find our inverses for our values in quadrant 4 and our values in quadrant 1, okay? All right, tangent is your y divided by your x. So remember that? Tangent is our y divided by our x. So what is the tangent of negative pi over 2? Undefined. Why is it undefined? Your zeros in your denominator. All right, negative pi over 3. AKA 300. Is it positive or negative? Negative.
Yeah.
Over 3? Square root of 3 over 3?
No. Just, you see nothing. You saw nothing at all. All right. My favorite one, tangent of negative pi over 4. 1, negative 1. Why is it negative? Because we're in quadrant 4, and the only things that are positive in quadrant 4 are cosine and its reciprocal, right? All right, negative pi over 6.
So yeah, then it positive square root of 3 over 2 over. Oh yeah, you just half. So is it times 2? So square root of 3 over 2 times 2.
What are y'all talking about?
2 over square root of 3.
It's 1/2. It's the y over the x.
So square root of 3 over 2.
Where y'all getting 2 from?
You put the 3 in the denominator.
Where y'all getting 2 from?
It's y over
I
x.
don't know.
It's y.
Why?
Okay, here we go. What is my y value at negative pi over 6? So y at 330 is what? 1/2. Right? And then what is my x value? Square root of 3 over 2. You keep changing, flip. So I'm going to be left with negative 1/2 times square root of 3 over 2. Sorry.
So it would be 1.
No, it's positive.
Cosine is positive. X is positive.
Oh, yeah. 2 over square root of 3.
I was fixing it. And what happens here? I'm left with negative 1 over square root of 3. What does that ratify to, guys? Negative square root of 3 over 3. Exactly. So what does it ratify? Forever. Okay. I was like, guys, why are y'all telling me there's no 3 in this denominator? It's negative because in quadrant 4, the only thing that's positive, cosine and it's reciprocal. And is this cosine? Yeah. All right. All right, 0. 0. 0. 0. Remember, it is okay to be in the 0 to be in the numerator, but it's a no-go for 0 in the denominator. Okay? Okay equals 0, no-go is undefined. Okay? It's going to be positive.
Yeah. So
Because everything is positive in quadrant 1. Yes? And so this is going to be a positive 1, positive square root of 3, and then undefined. That took us a little longer than I thought, guys. It's tangent is complicated, right? All right. Once you understand that, can you easily identify the angles that make A, B, C, D correct? Okay, let's do it really quick. Tan inverse of 1. What's my answer? Pi over 4. Tan inverse of negative square root of 3. Negative pi over 3. Tan inverse of 0. Tan inverse of square root of 3 over 3. Pi over 6. I know, we're gonna do great tomorrow. We got this. Got this. I'm not gonna cry.